Section 7.6 is talking about more identities and formulas to do with trig function. This time it is double and half angle formulas. So a double angle formula would be when you have something like sine of 2 times an angle. All of these formulas that we're going to derive them from the sum formulas that we talked about in 7.5. For example, the sine of 2 theta is the same thing as the sine of theta plus theta. So I'm going to apply the sum formula for sine to this. So the sum formula for sine is sine of alpha plus beta is equal to sine of alpha cosine beta plus sine of beta cosine alpha. But now alpha and beta are just both the same angle. So we have sine of the first angle alpha times cosine of the second, theta, times cosine of the second angle theta. Same sign because it's sine. Sine of the second angle theta times cosine of the first angle theta. So you end up with sine of theta cosine theta plus sine theta cosine theta, which just means you have 2 sine theta cosine thetas. So the double angle formula for sine is sine of 2 theta is equal to 2 sine theta cosine theta. So cosine of 2 theta, I'm going to do the same thing. Cosine of 2 theta is the same thing as cosine of theta plus theta. So I'm going to apply the sum formula for cosine. So if we apply the the sum formula for cosine, cosine of theta plus theta, cosine sum formula is same trig function opposite sign. So you get cosine of the theta times cosine of theta minus sine of theta times sine of theta, again because your angles are the same. So you end up with cosine squared of theta minus sine squared of theta. So you'll notice that I have 3 spots here for the cosine of 2 theta. This is the main cosine double angle formula, cosine squared minus sine squared. You can actually derive 2 other cosine double angle formulas from this one. So we've always talked about when you have squared trig functions, you should be thinking Pythagorean identity. So I can use the Pythagorean identity to derive 2 other cosine double angle formulas. So if you remember the Pythagorean identity, sine squared plus cosine squared is equal to 1, I'm going to use that to replace one of my trig functions. So I'm going to replace cosine squared with a 1 minus sine squared. So if I replace cosine squared theta with a 1 minus sine squared theta, you get 1 minus sine squared theta minus another sine squared theta, so you end up with 1 minus 1 minus 2 sine squared theta. So we still have one more. So starting back at the original one again, I have cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And now instead of replacing cosine squared with 1 minus sine squared, I'm going to replace sine squared with 1 minus cosine squared. So if you replace sine squared with 1 minus cosine squared, you get cosine squared minus the quantity 1 minus cosine squared, which gives you cosine squared of theta minus 1 plus cosine squared theta, or 2 cosine squared theta minus 1. So for cosine 2 theta, we actually have 3 different ones. You could just memorize the first one, and then if you need the other 2, you could derive it. They're useful to know. There's certain situations where maybe you just know sine or just know cosine, so one or the other is useful. But you at least need to know the original one. And then the last one we have down here, we have the tangent of 2 theta, which is equal to 2 tangent theta over 1 minus tangent squared, which again is derived from the sum formula for tangent. Half angle formulas. So half angle formulas, if you have sine of alpha over 2 or theta over 2, it doesn't matter, then you can apply these half angle formulas. So for instance, if you want to take the sine of pi over 12, pi over 12 isn't on the unit circle, but pi over 6 is. So you could say it's sine of pi over 6 divided by 2, and then apply this half angle formula. You'll notice there's a plus or minus here. That's because of how they're derived. So you do have to do a little bit of thinking and think, okay, what quadrant would this angle be in? And in that quadrant, is sine going to be positive or negative? So my example of pi over 12 is in the first quadrant, so would sine be positive or would sine be negative? Well, in first quadrant, sine's positive, so I'm going to pick the positive answer out of this half angle formula. So now let's try an example. We have cosine of alpha is equal to negative 3 over 5, and they tell us that alpha is between pi and 3 pi over 2, so basically they're trying to tell us that it's in quadrant 3, and we want to find the values of sine of alpha over 2, cosine of alpha over 2, and cosine of 2 alpha. So in this case, just like when we were doing our sum and difference formulas, we need to know sine of this angle alpha, so we're going to have to draw a triangle. So go ahead and pause the video, draw a triangle in the correct quadrant, and figure out the missing side. So now we have our triangle in the third quadrant. It's a 3, 4, 5 right triangle. So we can use this triangle to solve for any other trig function that might be needed. So let's start with part A, the sine of alpha over 2. Go ahead and pause the video and use the half angle formula for sine to evaluate this expression. So half angle formula for sine is plus or minus the square root of 1 minus cosine of alpha divided by 2. So if I apply this, well, we know that cosine of alpha is negative 3/5. That was given in the problem. So you end up with 1 minus negative 3/5 over 2, square root of that. So that simplifies down to plus or minus 2 over root 5. So now we just have to decide, is it going to be positive or negative? If the original angle is down here in the third quadrant, and you cut it in half, then the angle alpha over 2 is going to be somewhere in this top half. So in this top half, is sine going to be positive or is sine going to be negative? Well, in this top half, sine is going to be positive. So you want the positive answer. So your final answer is positive 2 over root 5. So go ahead and pause the video and try the cosine of alpha over 2 and also the cosine of 2 alpha. Cosine of alpha over 2 is plus or minus the square root of 1 plus cosine of alpha over 2. We know what cosine of alpha is. That's negative 3 over 5. So if you simplify this, you end up with plus or minus 1 over root 5. So now again, you have to decide what quadrant is cosine of alpha over 2 in, or what quadrant is alpha over 2 in. If alpha is in the third quadrant, if you cut it in half, it's going to end up here in the second quadrant. So for the third quadrant, okay, you're between pi and 3 pi over 2. So if you cut everything in half, and you're looking at alpha over 2, then alpha over 2 is between pi over 2 and 3 pi over 4. So that would be fourth quadrant. So we want the negative answer. So we're going to take negative 1 over root 5. So one way you can figure out what quadrant your angle is going to be in is if they give you the domain of the original alpha. In this case, we want to divide it by 2, divide everything by 2, and you can find the domain of your alpha over 2. For cosine of 2 theta, you have 3 different options for your double angle formula for cosine. You could use cosine squared of alpha minus sine squared of alpha, 2 cosine squared alpha minus 1, or 1 minus 2 sine squared of alpha. Any of those will give you the same answer. I used 2 cosine squared of alpha minus 1 because cosine of alpha was the given. So apply that and you end up with negative 7 over 25. So these formulas, along with the sum and difference formulas, are ones that you're going to have memorized. They're going to show up and be useful in the future.